There we go. All right, so we can start talking here. When we last met, we were dealing with the quadratic formula. And you had several delta math assignments, 3 of them. One of them, the solutions were rational numbers, fractions or integers. Another one, the solutions were radical numbers, where you just left the answer as a radical. And then the last one, you were supposed to take the radical, go to your calculator and change it to a decimal and change the whole answer to a decimal. So that's where we left off. Now this morning, we're going to do one last assignment from the book on the quadratic formula. And it involves part of the quadratic formula, which is called the discriminant. And that's the value that's under the radical. And that's going to tell you how many solutions you have. So first of all, I should remind you to make sure you get your notebooks out so you can take notes on these. I got 2 boards full of notes here. So we're going to talk a little bit about the discriminant and do some problems. Then we're going to get into section 9.7, which is the last section we're going to cover in this chapter. And we have a quiz tomorrow on 9.6, the quadratic formula. And with quizzes, it's being given tomorrow. You should do it tomorrow because you have to turn it in by 8 o'clock Wednesday morning. So you should always do the quizzes the day they're assigned and make sure you get them in to me. It's just like normal class. We take the quiz, it's done that day. And then Wednesday, we have a delta math assignment on this new material. And then Thursday and Friday, we do review assignments to get ready for the test. So we don't need to meet Wednesday and we don't need to meet Friday this week. Okay, today will be the only day we're meeting. And then next Monday, we don't need to meet because you're taking the test, Monday and Tuesday. So our next meeting after today will be next Wednesday. All right, next Wednesday where we start some new material. All right, so let me get started here and you can see what we're talking about. So what we're talking about is called the discriminant. And what it does, it discriminates as to how many solutions you have to your quadratic equation. Can we see all right?
Yeah.
Everybody see okay?
Mm-hmm.
So if we let D be the discriminant, it is the expression that's under the radical. Opposite of B plus or minus the square root of B squared minus 4AC all over 2A. And so the B squared minus 4AC, that's the discriminant. Notice, it's not the square root of that. It is that expression. That's what you compute. So you're going to take equations, evaluate A, B, and C, and plug them into this formula here and come up with the discriminant. And then this is what it tells us. If that D, that discriminant, is positive, then we know we have 2 solutions to your quadratic equation. All right, there are 2 solutions. And if you were doing a graph of the equation, that would tell you you have 2 x's making y 0. You would have 2 x-intercepts to your graph if your discriminant is positive. Now, if the discriminant equals 0, well, now you have negative b plus or minus the square root of 0 over 2a. And so you're only getting one solution now, because you have plus and minus 0. That's not giving you two numbers. Then you have one solution, and if you were graphing your equation, you would have one x-intercept, and that would be the vertex on the x-axis, because the solution would be negative b over 2a, which we know is the x value of the vertex. And then now, if the discriminant is less than 0, negative, then you're dealing with the square root of a negative, and that's undefined. So you would have no solution when the discriminant is negative. All right, so the discriminant positive, 2 solutions. The discriminant 0, 1 solution. The discriminant negative, no solution. All right, here are 3 examples in which we're going to find the discriminant and see what we have. So for this first problem, A is 2, B is 7, and C is negative 15. So what is B squared? It's 49, right? Minus 4 times, then we put AC in parentheses. AC is negative 30. Don't take the square root of that. Just take that expression. And so you get 49 plus 120, which is 169. And so the discriminant is positive. And so this equation has 2 solutions. And another thing we know, if the discriminant's a perfect square, which 169 is 13 squared, then the solutions will be rational. So we know more than that there's 2 solutions, they are 2 rational solutions, which could mean fractions or integers, if we wanted to know that. But if the discriminant here was positive, 169. So we have 2 solutions. All right, take this next problem. A is 1, B is negative 12, and C is 36. So now we get B squared, which is 144, minus 4 times AC, which is 36. And 4 times 36 is 144. And so your discriminant here is 0. So this equation has 1 solution. It has only 1 solution. The discriminant was 0. So you just get the negative b over 2a, because you got the plus or minus 0. So that's all you're doing. Compute the discriminant and then say how many solutions you have. And then let's take this equation. Can you all see it?
Yeah.
All right. So b squared would be negative 4b squared, 16, minus 4 times AC, which is 13. And so you get 16 minus 52, which is what? Negative 36? And so the discriminant is negative. So this equation here has no solutions. And we can see here that there aren't going to be any numbers that are going to make this true. Because when you apply the quadratic formula, you get the square root of a negative, which is undefined. All right? Do we get this? Everybody? Are we good?
Yeah.
Yeah.
Okay, so this is discriminant. The b squared minus 4ac tells you whether you have 2, 1, or no solution. All right, so that wraps up the quadratic formula. Okay, now get your notebook there. That material should have still been with 9.6. Now we start the next section. The last section we're going to cover, 9.7. And it is solve systems with linear / quadratic equations. We've solved systems of linear equations where both equations were linear. This is the first time we're solving a system of two equations where one of the equations is linear and one of them is quadratic. And we want to know what type of solutions we're going to have. Well, think about it. The solution to a system of equations, if you remember, were the intersection points. It's where with the linear systems, it's where the two lines intersected. That was the solution to that system. Well, now it's where the line and the parabola intersect is going to be the solution set. And so here's three possibilities you're going to have. In this first case, the quadratic is this parabola, the linear is this line, and we can see that that line is hitting that parabola in 2 points. So that linear quadratic system would have 2 solutions if that's the situation. And then you could have a parabola and a line like this, where the line hits the parabola in only 1 point, and you have just 1 solution to that linear quadratic system. Or you could have a parabola here and a line down here in which the line doesn't hit the parabola at all. There are no points of intersection, so there are no solutions to this linear quadratic system. All right, so those are the 3 possibilities. 2 solutions, 1 solution, and no solution. It's kind of like what we just did with discriminant. Only now this is different. This is a system of a linear with a quadratic. Okay, now, here's a system. Here's your linear, y equals 3x plus 2. That we know is a line. Here's your quadratic, y equals 3x squared plus 6x plus 2. This is a linear quadratic system. And we want to know the points of intersection. Now, there are 2 methods we can use to solve this system. 2 methods. The first method is we could graph these 2 equations on a graphing calculator. So get your graphing calculator out and let's see if we can come up with them. Get your graphing calculator and go to y equals y sub 1 and put y1 equals 3x plus 2. Then go down to y sub 2 and put y sub 2 equals 3x squared plus 6x plus 2. So put those two equations in your y1, y equals button and write both equations down. Then we're going to go to Zoom Standard. Go to Zoom Standard and hit enter and see what the graph looks like. And I know this one happens to have two solutions. So your picture should be a parabola with a line intersecting the parabola twice. We should have 2 points of intersection. Are you doing this? Yes or no?
Yes.
On your graphing calculator. Is that what you got?
Yes.
Did you get a picture of a parabola with the line crossing it twice?
Yeah.
All right, next you need to go, let me get my calculator here. You need to go to calculate on your calculator. C-A-L-C, second brace, calculate. And then you go down to intersect. You hit the intersect button. Go to calculate, then go to intersect. Now take your cursor and of the 2 points of intersection, start with the one furthest to the left and move your cursor to the left of that intersection point. And then hit enter, because it'll say left bound. Then move it to the right of the intersection point and it'll say right bound and hit enter. Then it should say guess and hit enter. And it should give you the point of intersection. And that point should be what? What's the coordinates you get?
0, 2.
You got 0, 2?
Yeah.
Shouldn't you have gotten the -1, -1 first?
Yeah, I got both.
Okay, you should get both of them. Once you get one of them, then you start back again and you go back to intersect, then you go to the other point of intersection, go to the left, hit enter, go to the right, hit enter, guess, hit enter, and it'll give you that point of intersection. And it'll be these 2 points, 0, 2, and -1, -1. Can we see them now? 0, 2, and -1, -1. So that's one method for solving a linear quadratic system. You put them both on the graphing calculator. You go to Zoom Standard, do the graph. You should see, in this case, the line hit the parabola twice. You should then go to intersect. After you go to calculate, go to intersect, and then check out both points of intersection to the left and to the right, and then get, hitting enter. And it'll give the coordinates of the point of intersection. And that's how we can do this second one. And I have a third one here yet that we're going to look at. So that's one method. the method of graphing on a graphing calculator. All right? Now I'm going to show you another method for solving this, called the substitution method, where you do it algebraically. You don't use a graphing calculator. So here we have a linear and a quadratic, and they're both equal to y, so we can substitute. So what I'm going to do is this y, I'm going to substitute this y, 3x squared plus 6x plus 2. So that's going to end up equaling 3x plus 2. And so you get this equation, 3x squared plus 6x plus 2 equals 3x plus 2. Just substitute this for y. Then we get this. Now bring the 3x over and the 2 over, and the 2's cancel, and you get 3x squared plus 3x equal to 0. And now we just have to solve that equation. Now that's not a trinomial, but this is solved by GCF. You take out a 3x, you're left with x plus 1 equal to 0. And then you set 3x equal to 0 and get x equals 0. Take x plus 1 equal to 0 and get x equals -1. And then for x equals 0, go back to the linear equation or the quadratic, either one, and plug in 0, and what do you get for y? You get 2, don't you, whether you plugged in here or here. And that gives you the ordered pair 0, 2. And then you take the -1 for x, and again, either plug it here or here. You're probably best plugging it into the linear. 3 times -1 is -3 plus 2 is -1. And that's how you solve this system by an algebraic method called substitution. All right? Does that make sense?
Mr. Tilly, how
Yes.
did you go from 3x squared plus 3x to the 3x times the quantity 1
All
plus?
right, I factored out 3x. 3x is the greatest common factor. So you take a 3x out, you're going to be left with an x plus a 1.
Okay, I got it.
You're solving by factoring. It's not a trinomial. So we don't have to factor it as a trinomial. We factor it by greatest common factor. And a 3x came out. And now we have a product equal to 0. You take each factor equal to 0. And you get your 2 solutions. So it's all material you've learned before. Okay? All right. Here's another system now. Y equals -2x squared minus 2x plus 3 with the linear equation y equals 7/2. That's a horizontal line, and that's a parabola. These are not these. These are just general pictures. This one is a parabola with a horizontal line. And we'll see how many points of intersection we have. So you could go on and put this into your calculator and then put this into your calculator and see how many points of intersection you get. It turns out you're only going to get 1 point of intersection. And then you go to calculate, intersect to the left, to the right, and come up with the answer. That's doing it by graphing. Here's how you would do it by substitution. we would take this and set it equal to 7/2 and get this equation. And then what I'm going to do is multiply both sides by 2 to get rid of the fraction. And it makes it minus 4x squared minus 4x plus 6 equals 7. You multiply both sides by 2. Then you bring the 7 over and you end up with negative. What I did is I brought everything to the right, made it positive 4x squared plus 4x, and then plus 1 equal to 0. And so we wouldn't start with the negative. I wanted to start with the positive x squared. And then this trinomial is a quadratic trinomial, and it happens to be a perfect square trinomial. It factors into 2x plus 1 squared equal to 0. And so you simply get 2x plus 1 equal to 0, which gives you x equals negative 1/2. And so that's the x. And then plug it into the y. Well, what this says is no matter what x is, y is 7/2. And if you plug the negative 1/2 in here, you would get 7/2. And that's why you get this as the solution. Negative 1/2 comma 7/2. So check that out. Make sure you get that in your notes. So this is solving by the substitution method. And again, you could have solved it by the graphing method. All right. Did everybody get this down?
Yep.
Are we done with this? Because I want to erase. I got one last problem for us, then that's it. All right, we got that? I'll work over here. Okay, so now I'm going to take the following system. Y equals 2x squared plus x minus 1 and y equals negative x minus 3. Take that system. Okay, again, you could go to your calculator and graph each of these and check. And what would you end up discovering if you did it by calculator? They don't intersect. So the answer here is going to be empty set. Let's see what it looks like by substitution. I'm going to get 2x squared plus x minus 1 equals negative x minus 3. And then that gives me 2x squared, the negative x comes over, plus 2x, the negative 3 comes over, gives you plus 2 equal to 0. Divide both sides by 2, and you get x squared plus x plus 1 equal to 0. And now you need to solve this equation. But if you try to factor it, you can't factor it. So the only way we can solve it is quadratic formula. But what we're going to do is first check the discriminant to tell us how many solutions we have. So b squared is 1 minus 4 times ac is 1, and you end up with negative 3 is the discriminant. And what does that tell us? Empty set. You get no solutions. Does everybody see it? All right. Those are the two methods that we have. You can do it on a graphing calculator, or you can do it by substitution.